Hello everyone, welcome to our channel Code with Sunny, and in this video I will be talking about the very first problem of May Circuits 2021 of Hackerearth, and the problem name is binary inversions. Okay, so before going into deep into this problem, I just want to say that actually I haven't given this contest since I were very busy regarding my internship. Okay, so now I just wondered to basically discuss this problem for the betterment of yours, to understand the concept if someone is getting some difficulties in solving this problem or the further subsequent problems that I am going to discuss, then it will be helpful to you. Okay, so this problem is basically involves a brute force technique or simple basic maths, and you can see the tags associated are inversion count, sorting algorithms, advanced sorting. I don't think so. So, okay, so without wasting our time, let's discuss this problem. We have to construct an array A of size n with A, and there is a condition A should be less than equal to n, that is A amount of zeros and B amount of ones, and B is basically n minus E, and such that the number of inversions in the array is exactly equal to x. If you're not aware of the inversions, the definition of inversion, no need to worry about. I am just going to explain that also. And okay, what we have to do, we have to print a space separated lexicographically smallest array that satisfies the constraints. If there is no valid answer, print -1. And there is a definition of inversion is given. Note that we have to print a lexicographically smallest array, that is that have the number of inversion equal to x. But there may be some more arrays present over there whose inversion count is x, but we need to print the smallest lexicographically array satisfying the given conditions. Note that the length of the array can go up to 10 power 6. So we need to find an efficient solution either in O of n time or O of n log n. I think O of n would be sufficient to solve this problem. And also x is 10 power 12, number of inversion count, and number of zeros is going to vary up to at most length of the array. So let's move further to understand this problem with the help of some examples, and we will together build up the idea to develop these type of to develop the solutions in these type of scenarios. Okay, so let's move further. Okay, so first let us understand the concept of inversions. That is, suppose we have been given this array like let us say 5, 4, 6, 9. So suppose there is an array of size 4, and these are the elements 5, 4, 6, 9. Okay, a pair of indexes I comma j is said to be like is included in the inversion count, that is I comma j. The values at these indices should be like in the, you can say, the should be included in the count of the inversions when and only when the values a of I should be greater than a of g. Note that I am talking about strictly greater than, and I should be less than g. Okay. You can also refer to the statement refer over here, but I am telling in the simple statement. Pair this is called an inversion of A if I less than J and A of I should be greater than A of J. Now you can easily see if I will consider A of I as 5 and I need to consider J such that J should be greater than I can consider 6, I can consider 9. If I will consider 6 and 9, you can easily see 5 is going to be less than 6. This condition is satisfying, but this condition is not satisfying. That is, a of I should be greater than a of g. So this 5 comma 6 or 5 comma 9 is not included in the inversion count. Then which pair should be included in the inversion count? If you look over the values 5 comma 4, you can easily see a of I is going to be greater than a of g, and I is less than g. Yes, 5 comma 4 should be included in the inversion count. So you can easily see this is the only inversion pair that I am going to find it out in this array. It means that a of I should be greater than a of g and I should be strictly less than g. Okay, so I need to just build up any array, then I need to find out the lexicographically smallest array. Now, so one thing that I should focus upon, that if we have been given a amount of zeros and the b amount of ones, and a plus b is n, basically you can see a plus b should be n, number of ones and number of zeros count should be n, and A is basically denoting the number of zeros, and B is going to basically denote the number of ones. Okay, so we need to find any array with A amount of zeros and B amount of ones, and that array should be lexicographically smallest. I hope you guys are understanding the concept of lexicographically smallest. So I'm jumping over the concept of this one. How I can build A amount of zeros of an array and B amount of ones such that the inversion count x, inversion count of this array should be x. Now, okay, so the one thing that you are aware of, that what is the inversion count? That is when the inversion count of an array is going to be minimum. Suppose we have an array like this, 2, 1, 5, 4. Suppose we have an array of this element 2, 1, 5, 4, and suppose if we have to say that we can sort this array as of my choice such that the inversion count should be 0, and the definition of inversion count should be I less than g, and the value should be specifying this condition, that is it should be satisfying this condition, a of I should be strictly greater than a of g. If we have to sort this array of my choice, I am always going to sort this array like this type 1 2 4 5, and this will give us the minimum inversion count, and minimum inversion count is always going to be 0. How it is possible? Always sort the array in the non-decreasing order. You can also say ascending order. Then all your inversion count will always come out to be 0. Okay, starting with this idea, suppose we have to build up for x amount of inversions in the given array, and we have a amount of zeros and b amount of ones. And let's say, okay, so let us start with this one. Suppose I have three amount of zeros and remaining, let's say two amount of ones. Okay, so I have built this array like this type, array of size 5, and I need to find x amount of inversions, and still x is unknown. I have not taken this x, but I have taken this a as 3 and b as 2. Now just try to focus upon that this array has number of inversions equal to 0. And if x is 0, I will print this array, and this array is going to be like lexicographically smallest, because I am not going to start with 1. If I will start with 1, that array would be that array would not be lexicographically smallest. For printing the lexicographically smallest, I should start with 0. I will always try to cover up 0 first, then cover up 1 for considering the lexicographically smallest array. Okay, so this array has inversion count 0, and suppose x is 0, then I will print this array, and if x is going to be 1, how you can modify this array such that number of inversion count would become 1? Then you can say I can just modify this array by bringing 1 over one place to the left. If I will do like that, that is, if I will bring one of the 0 to the right of one of the 1, then you can easily see I have this inversion count as 1 for this pair. 1 comma 0 is contributing to this pair. So my inversion count would become 1. And if I have been asked to what is the inversion count of 2, that is what is the suitable array for the inversion count equal to 2, you can easily see I will bring up 1 0 to two places right, that is these two ones will come shift by one position. How I am going to do that? You can easily see my new array would become 0 0 and again 0, and you can easily see I'm not considering this 0, sorry for the mistake. I am just considering 1 over here, then 0 and then 0. Okay, so this is the array whose inversion count is coming out to be 2. And how? You can easily see 1 0 and this 1 and this 0. Inversion count is coming out to be 2. Can you say that this is the, okay, this is the only possible array? Can we have some more arrays whose inversion count is 2? Yes, I can have. In spite of bringing a single 0 to the right, I can bring two zeros. That is, my new array should become 0 0, then 1, then 0 0, then 1. This is also an array. I think the size of the array is exceeded by 1. I think this is okay, so I should have to consider like that, 0 1 0 0 1. So this array has also the inversion count of equal to 2. Now we need to consider that which array is lexicographically smallest array for x equal to 2. you can easily see this is the smallest array, because the first position that is has the smallest value is at this position 0, and here position is 1. So this array is going to be like lexicographically smallest array. I need to consider for this position. So it gives me the idea that if I have X amount of inversion count, I will try to first shift my first 0, that is this is the base value, base array, you can also consider that. I will, if my inversion count is X, I will try to shift this 0 to the right of 1 such that X inversion count is still not 0. That is, if you're not try understanding this concept, no need to worry about. Let us take another example and let us try to understand this in the best possible way, and also I am going to generalize the statement also. Okay, so let me first erase this stuffs. Okay, almost done. What has happened? Okay, so what I am saying that suppose I have taken these three amount of zeros and these two amount of ones. If my inversion count is X, I will try to first make this zero to the right of the ones by one place right, then inversion count will decrease by one, then one place right, then inversion count will decrease by one. First I will try to shift this zero, and after shifting this 0 to the suitable position, if my X is still not 0, that is, if on shifting this 0 by 1, my array would become this one and inversion count of this would be X minus 1, and again this position occurs, my inversion count will become X minus 2. And if I need to find the suitable array for lexicographically smallest array for inversion count of X minus 3, I should focus on the next 0 to put this 0 to the suitable position such that the inversion count would decrease by 3 and my array would be lexicographically smallest array. I would do like that: 0 1, then 0, then 1 1 0. Note that the inversion count decreases, or you can say inversion count increases, because I need to make our array inversion count equal to X. That is, I am doing in a reverse manner, I am decreasing this X. So inversion count is contributed by this pair. Okay, so I'm just shifting this one, and if I need to find for the X minus 4, that is, I need to increment my inversion count by 1 again, I will shift this 0 to the right of this one also. I think I have done a mistake over here. There are not two ones, there are single ones. Okay, so I will shift this 0 to another one place, so my array would become 0 1 1 0, then 0. So this gives me the idea that first I need to find it out what are the number of zeros that should be present to the right of all the ones. And let us say if I have these amount of ones, okay, and let us change the color. If I have two amount of ones, what are the number of zeros that is going to present over to the right? And you can easily find, suppose X is going to be like 5, then I can easily find X by number of ones present over here. And if I will take the integer value of division X by 1, and if my X is 5 and number of ones is 2, I will find 5 by 2. 5 by 2 integer value is coming out to be 2. It means that there will be two amount of zeros that would present to the right of all the ones. So my array would be like this one: 0 1 1 0 0. You can easily see the inversion count is coming out to be here 4, and you can easily see there are two ones and two zero. Inversion count will be 2 into 2, and still my I have covered this 4 number of inversion count equal to 5. I need to cover up the inversion count 1 also. So I will try to shift this 1 now, and how much I have to shift? Only one time. So I will shift this 0 to one time. It should become 1 0 1 1 0 0. This is my answer: lexicographically smallest array. Now, if you have been asked what is the maximum number of inversions that can occur in this array with A amount of zeros and B amount of ones, then you can easily see maximum number of inversion would occur would be A into B. And this would happen when the array is sorted in decreasing order, like 1 1 0 0 0. Everyone has the all the zeros present over to the right. It like 3 would occur, and then this for this one all the zero is to the right of this one, then 3 would again occur, then 3 plus 3 is 6. You can also write number of zeros into number of ones. This is the maximum number of inversions that can occur in the array with a amount of zeros and b amount of ones. The concept is very clear. Find the integer division of x by 1. It means that this amount, let's say this is p amount of zeros would occur to the right of all the ones, and we will print this like this in this fashion. You can here see I have print the 2 amount of zeros to the right of all the ones. Then I will find the remainder of x modulus 1, that is the remainder obtained when x is divided by 1, and that amount of shifting is done by the latest 0 present over to the left of first occurrence of 1. You can see first occurrence of 1 is 0 and latest 0 is 0, this position. I will shift this 0 to the right by x modulus 1 position. Okay, if you're not going to understand still now, no need to worry about. If you look over the code, it will be easier to understand, to interpret, and to find out the logic behind also, because I have written the code in much more simpler way. Okay, so let's move further. Okay, so you can easily see I have a code over written over here. I will try to expand this. Can I expand this one? uh, I don't know. Okay, so let us try to do over there. Okay, so no need to worry, but I'm just going to explain over here. I think this is very small. Okay, so I've taken this long 1 as n minus a, and maximum would be number of zeros into number of ones, maximum inversion count. And if x is going to greater than mx, I will print minus 1, because there is no suitable array present. Otherwise, I will have to print the suitable array. Note that I have first printed this one. This is going to denote, or that is my pattern of printing would be like this one. Okay, so I will say some amount of zeros, then followed by some amount of ones, then a single zero would present or not, then some amount of ones, then some amount of zeros. This is going to be pattern. Okay, so this would be like either zero can be present or zero can't be present depending upon x is a factor of this one or not. Okay, so this will basically correspond to printing some zeros, then printing some ones, then it would correspond to printing zero. Either we have to print zero, otherwise we are not going to print zero depending upon this division, and then some ones, then some zeros. Okay, so first I will try to print the some zeros, and how it would be possible. I will try to start with the looping with I equal to 1, and I will print up to a minus x by 1. Suppose this division is like saying that I have to print x by 1 amount of zeros to the right, then remaining would be a minus x by 1, and I need to consider for this division also. If this division x modulus 1 is non-zero, I need to print 1 0 less, because that 0 should be printed in between over here, that is this position. Okay, so I will first print that amount of zeros, and suppose if x is not a factor of 1, that is x remainder, I'm getting some remainder when divided by this 1, I will print like that. First sum of the ones, and that amount of ones would be x modulus 1 times 1 I am going to print, and then followed by printing this 0 a single time, then the printing this remaining ones. Okay, and else that is this is going to happen for 1 some 0 1, then some single 0, then some ones, then followed by this this printing I equal to 1, I less than x by 1, x by 1 times of zeros I will print to the last, and this is going to be common for either x is a factor of 1 or x is not a factor of 1. It doesn't matter, I will have to print this 0 at the last time. So I have just separated these two conditions for this one. Okay, 101, and otherwise I have to print the entire ones, all the ones in between if x is a factor of this 1. Okay, so this should give us a all test cases passed. We have to print this array in this type also. You can easily see everything is going to be accepted, all test cases passed. So if you have any doubts, do let me know in the comment section of the video, and I will recommend to subscribe to our channel, like to our video for the latest updates regarding contests, online contest, and competitive programming topics, and do join the Telegram channel link mentioned in the description. description section of the video, and thank you for watching this video.